So let's start with the acids and alkali sheet, the hazard sheet. If you look here, the symbols have been matched up. So the hazard symbol for toxic is the first symbol. The second symbol is the symbol for a flammable substance. The third symbol is a health hazard. The fourth symbol is a irritant. The fifth symbol is the symbol for corrosive materials or substances. And the final symbol is for an explosive substance. Okay. Now, the definitions or descriptions are on the right hand side. So, a corrosive substance is a substance that may dissolve or burn materials, including skin. A health hazard, this contains dangerous organisms such as bacteria. Explosive, it's quite obvious, this may explode. Flammable, this can easily catch on fire. Toxic, this can be poisonous and possibly deadly. And a caution or an irritant, it's in the description. This includes irritants, harmful substances, and some low hazard substances. The next part was identifying all the precautions you will take when working with hydrochloric acid. It's a strong acid, so what kind of precautions would you take? It says that the labels on the hydrochloric acid bottle would be the corrosive label and the irritant label. Now we can go back to just to remind ourselves what corrosive was. So this may dissolve or burn materials, including skin. So that's your skin that could damage. Also, it could burn materials such as your books that are on the table when you're using this. Then it says it's an irritant as well. So this includes irritants, harmful substances as low hazard substances. So it could be an irritant to your skin, to your eyes. So where the substance is hydrochloric acid is reacting with your skin. Not enough to burn it, but enough to cause a chemical reaction. But with corrosive, it will possibly burn your skin as well. So I have ticked wearing eye protection, as we do in majority of our experiments with chemicals. There's a bottle. Most acid bottles will have a lid. So we've got to keep the lid on. Use proper glassware. So often we use beakers when we are pouring acid from one container to another. Any slippages off. So wash any spillages with plenty of water. Okay, so if some acid falls onto your skin, then you need to wash it off immediately, because you want to dilute the acid so that the chemical reactions that may possibly take place between the acid and your skin have a reduced effect, and you try to remove the chance of any chemical reactions taking place which would cause damage to your skin. Proper glassware, well, you don't want the acid to react with the container, so we need containers that do not react with the acid and produce chemicals more unwanted chemicals. So using proper glassware, laboratory equipment is essential. Keeping the lid on the ice, why is that essential? Now, if the bottle tips over, you will reduce the chance of spillages. That's where I was thinking of the word spillages. Right. Okay. Um, so what we'll get is less chance of the acid going everywhere. And the effect of, if you were hovering over the bottle, you were not inhaling the acid that may have got into the atmosphere. Eye protection. Often we touch our eyes. If your hands got covered in acid, then you stick your hands, rub your eyes. The acid will then hit your eyes and cause a chemical reaction. So one, it's the off chance that you touch your eyes. The second thing is there's a possibility that the acid could get into your eyes by it bouncing off something, or if it was being heated and it's spitting. Wearing steel toe cap shoes. We're not on a building site. Generally, our room's well ventilated. You could include that. We have the AC on generally, and we have a big room. A face mask is not necessary in this scenario. But if we were working continuously with chemicals, then you would consider wearing a face mask. And temperature, generally the lab temperature is around 20-25 degrees anyway. Often you won't conduct this experiment outside because the effect of temperature does increase the reaction rate. So you could include that as well.